Hello, my dear students. Let's get started with today's session. In this video module, we are going to solve a few problems from geometry, and all the questions that you are going to see, they are pertaining to polygons. So let's get started with the first question here. Take a look at this question. In this question, you can see that it is given, there is a figure where triangle ABC and triangle GFH, they are given to be equilateral triangles. It is also given that DEFG, the quadrilateral, it's a square. You are asked to find the measures of angle GAD and angle HDA. Okay, so for our clear understanding of this question, let me present the given diagram in a slightly enlarged fashion. Okay. So let's see what all things are given. Triangle ABC. So we have this vertex A here, B here, and C here. This triangle is given to be equilateral, right? Which means I can see that this angle, it has to be 60 degrees, right? I can see that this angle over here, angle C, this has to be 60 degrees. And in the same way, this angle over here, the full angle, it has to be 60 degrees, right? Now, consider triangle GFH. So let's focus on the vertex here. G is here, F is here, and H is here, GFH. It's given that triangle GFH, it's also equilateral. So I can consider that this has to be 60 degrees. This has to be again 60 degrees, right? And in the same way, angle H, this also should be 60 degrees, right? Now, what's the next thing that is given? DEFG, the quadrilateral, it is a square. So let me look at the vertices here, D, E, F, and G. Already I have highlighted this F and G. We have the vertex D here, vertex E here. This DEFG is given to be a square, right? So I can consider that this will be 90 degrees and this will be 90 degrees. Same way, I can consider angle DGF. This has to be 90 degrees. And angle GFE also, it should be 90 degrees. But already we have considered that this angle, it is 60 degrees. So I can consider angle HGD. Observe closely, HGD. It has to be 30 degrees, right? Because 60 plus 30, that comes as 90 degrees. So I shall just note that number here. This has to be 30 degrees. And same is the case here. Okay, this has to be 30 degrees, right? Now also, since this DEFG, it is a square, DE, it should be parallel to GF. If I am considering it in a slightly extended way, this BDEC, which is a straight line, this GF, it is also a line. If I view it that way, I can consider that this GF and BC, they are parallel to each other. Okay, just look here. I'm going to extend this like what you see here. Look at this. So can you not see that this is one line, this is another line. They are parallel to each other. This AGB, I can consider it as a transversal. So this 60 degree, what you observe here, correspondingly, this also will be 60 degrees. Okay, because they are corresponding angles. I can say this measurement has to be 60 degrees. In the same way, you can consider this is parallel. GF is parallel to BC. Since this is 60 degrees, corresponding angle, I can see that this also should be 60 degrees. And that gives us the insight that triangle AGF, it is also equilateral. Look at triangle AGF. It is also equilateral, right? So, with all those equilateral triangles there, let me now focus on the side aspect. Okay, so for better understanding, let me zoom this slightly more. Okay, now let's look at the measurement of the sides. Okay, so we can see that here GFED, it is a square. So all these measurements, the length when I'm considering, it will be the same, right? And I can see that here triangle GHF, it is equilateral. It is given in the question. So I can consider these measurements also will be equal. We can see GH here. We can see FH here. These measurements are also equal. Lengthwise GH and our FH, they should be equal, right? And look at this triangle AGF, it's equilateral. So we can consider that these lengths are also equal. AG and AF, they are equal. So whichever be those lengths that are going to be equal, I have marked it like what you are seeing there, right? Now, if I am considering this particular diagram further, they are asking you to find the measures of angle GAD. So where is GAD located? G to A to D. What is the measurement of this angle? I shall highlight it with red color. Okay. So GAD, this measurement you are asked to find out. And HDA, we can see that H is here. H and D, they are not directly connected. So I shall do that first. H to D, HDA. So we need to find out what is the measurement of this region, HDA. These are the two angles we have to calculate. Okay. Now, before I proceed further, just observe. I want you to observe triangle GAD. G is located here, A is located here, and D is located here. Look at this triangle GAD. Don't you see that GA and GD, they are equal? Don't you see that? GA and GD, the length is equal. You can see they are equal here, right? Now, I want you to look at the angle here, 60 plus 60, 120 plus 30, 150. This total, it comes as 150. Pending it is 30, right? 150 plus 30, 180. So that triangle GAD, sum of all the internal angles, it is 180. 60 plus 60, 120 plus 30, it is equal to 150. Remaining 30 degrees. That 30 degrees will be equally divided between these two angles. GAD and GDA, they measure 15 degrees each. So I can just write here this angle, this small angle here. I can say this corresponds to 15 degrees. In the same way, over here, this small angle, I can consider that corresponds to 15 degrees. I hope that part is clear to you. I have marked it. Okay, just to avoid confusion, I'm just removing it and I will write it separately. In triangle GAD, I can see that angle GAD, it will be equal to angle GDA. You can say both corresponds to 15 degrees. I am saying they are equal because GA and GD, they are equal in measure. So it's an isosceles triangle. Base angles, they will be equal, right? So 15 degrees each I got. I hope that point is clear to you. Now, I need to focus on triangle. We need to find the value of HDA, right? That measurement we have to find out. Okay. So for that, we can consider triangle when I am observing. Just a second. Yeah. We can consider that this is 30 degrees. I want you to focus on triangle. Observe closely. Triangle DGH. Please focus on the triangle DGH. D is here. D to G. and G to H, DGH. You can see here DG, it is equal to GH. This is 30 degree. Got it? So from that, I can say for sure that this angle GDH plus angle GHD, the total, this angle and the full angle over here, the total, it has to be 150 degrees, which means I can see that this has to be 75 degrees. In the same way, this full angle here, this has to be 75 degrees. Base angles, because this triangle DGH, D to G, G to H, it will be an isosceles triangle. I can see that GD and GH, they are equal in measurement. So I can see that the base angle, they should be equal. 75 plus 75, 150 plus 30, 180. The condition, it is satisfied beautifully, right? So this is 75, this is 75. But you already know that since this is 15 degrees over here, angle GAD, it is 15 degrees. Also, GDA, it is also 15 degrees. So I can thus infer that the measurement of this angle HDA, it has to be 60 degrees, because only then HDA, that corresponds to 60 degrees plus the 15 degrees over here. 60 plus 15, it comes as 75, the full measurement, right? So that way, when I am observing, in the question, we are asked to find the measure of angle GAD. I can thus infer that angle GAD, this has to be 15 degrees. And similarly, angle HDA, it has to be 60 degrees. So these are the two values that you are asked to find out. And thus we have attempted our first question here. I hope this explanation, it is clear to you all. All right, students. So I hope the first question is clear to you all. Now it's time for us to consider the second question. In the figure, it's given ABCD is a rectangle. A, B, C, D, it's a rectangle. Okay. It is given EF, it is perpendicular to DC. You can see that here F and EF, it is perpendicular to DC, the side. Okay. It is given FC, it is equal to 25. We have F here, we have C here. FC, this measurement, it is 25. The question is, what is the ratio of the perimeter of triangle DCF? DCF, D to C, C to F, the triangle, perimeter of the triangle to that of rectangle ABCD. ABCD, it is the rectangle. So they are asking you to find the ratio of the perimeter of triangle DCF to that of rectangle ABCD. Okay, so let me take this diagram that is given here. Let me present it in an enlarged way. Okay, let me zoom this. So we can just consider, I shall mark the distances that are given. It is by default, it is given that DE, in the question it is given, this is 8 units and this is 20 units. So that gives me the length of this given rectangle. I shall just write it here. The length of this given rectangle, please be aware, that is equal to 28 units. It's not in centimeters, it's not given. So I will consider L, it is equal to 20 plus 8, 28. Okay. Now, in the question, it is further given FC, it is 25. So you have F here, you have C here. So that segment FC, we can see that corresponds to 25. Okay. But if you observe this triangle, that is FEC that you are considering, this triangle, don't you see that it is a right angle triangle? And that too, we remember 3 4, 5. It's a Pythagorean triplet, right? 3, 4, 5. 3 square plus 4 square. It's equal to 5 square. It's a Pythagorean triplet. Just consider that I'm multiplying this Pythagorean triplet with 5. So I can say this comes as 15. 4 5s are 20. 5 5s are 25. So 15, 20, 25 should also be forming the Pythagorean triplet. And if you observe, we can see we have this 25 here, we have this 20 here. So the missing link FE, I can see that it should be equal to 15 units. Clear? So that you are getting a right angle triangle here, 15 square plus 20 square. It is equal to 25 square. Okay, so just if you are able to remember that Pythagorean triplet aspect, what I have just mentioned, you can arrive at that 15, FE, it is equal to 15 very fast. Otherwise, you can do 25 square minus 20 square. You will get it as 225. Square root of 225, you will get it as 15. That way also you can do. Okay, but the better method, it will be remembering the Pythagorean triplet and then work out the question. Okay, so I have understood that here the breadth of this particular rectangle ABCD, that value it is equal to 15. So with this, can you not find the perimeter of this given rectangle? You know the formula, the perimeter, when we are considering the perimeter of the rectangle, it is 2 into L plus B. So that will be nothing but 2 into 28 plus 15, right? So 28 plus 15, 28, 38, 39, 40, 41, 42, 43. Okay, so the total is 43. 43 into 2. When you are considering, that value will come here as 86. Okay, so this value, I can say this will come here as 86. 43 into 2, 86. That's the perimeter of the rectangle. So I have identified one value here. Okay. Now, if you observe this particular triangle FED, look at FED. F is here, E is here, D is here. It is a right angled triangle. You see a 15 here. You see an 8 here. I can consider this to be the base, this to be the altitude. So can I not find the hypotenuse FD here? Because it's a right angle triangle. How will I do that? I can see that FD square, that corresponds to 15 square plus 8 square it will come. You can say FD, the value, it should be equal to 17 in that case. Right? Because 15 square is 225. 8 square, it is equal to 64. So this comes as 289. FD square is 289. And that gets me FD, it is equal to 17. So I'm writing that value here as 17. Got it? Now, will this not empower me to find the perimeter of our triangle DCF? Look at triangle DCF. I can see the perimeter will be nothing but 17 plus 25 plus 20 plus 8. So when I'm doing it, please see 17 plus 8, that is equal to 25. 25 plus 25, 50 plus 20, that is equal to 70. So I can see the perimeter of the triangle. I shall write it here. The perimeter of the triangle, that is equal to 25 plus 25, 50. 50 plus 20, that is equal to 70 I am getting, right? And also I have just calculated the perimeter of the rectangle, that is equal to 86. You are asked to find the ratio of the perimeter of the triangle to that of the rectangle. So we can say that will be 70. That of the triangle is to rectangle, that is 86. I can take 2 the common factor out. So this comes as 35 is to 43. Got it? So the ratio, it is equal to 35 is to 43. For this question, my answer, I can write it 35 is to 43. Okay. So with this, we have reached the conclusion related to the second question. Any doubts? Please let me know. Students, take a look at the next question here. In the figure ABCD, it is a parallelogram. BD, the diagonal BD, it is equal to 24 centimeters. AC, the other diagonal, that is equal to 4 root 14 centimeters. AB, one side, it is equal to 16 centimeters. You are asked to find the length of AD. Okay, this AD, what is the measurement? That is the question. So let's get started with the question. But before I proceed further, some properties related to parallelogram and also triangle we need to quickly recall. So please note, as far as a parallelogram it is concerned, the diagonals of the parallelogram, please be aware. The diagonals, let me reduce the font size. So as far as the parallelogram, diagonals, they bisect each other. Okay, I cannot say that the diagonals of the parallelogram, they are bisecting at 90 degrees, I cannot claim. But at least be aware that diagonals of a parallelogram, they bisect each other. That is one result you should keep in mind while attempting this question. What does that mean? We can see that here the measurement AC, and let me say that the diagonals, they meet at this point P. Okay, so I can see that AP and PC, they will be equal in measurement. AP will be equal to PC because they are bisecting each other. They are cutting exactly midway through. In the same way, DP will be equal to PB. Got it? They cut it exactly halfway through. Got the point? And also, we have to remember the Apollonius theorem. So how to consider that? I shall show you. Consider a triangle here. Just a random triangle. We have explained this already, but for your quick reference, I am narrating it once again. Okay, consider that there is a triangle ABC. Okay, let me say that the midpoint of BC, let that be P. So the midpoint to the opposite vertex, PA, understand that PA, it is the median. So as per this Apollonius theorem, be aware AB square plus AC square, that will be equal to 2 times AP square plus BP square. Okay, so this result, you can keep this in mind while solving this question. Apollonius theorem says AB square plus AC square, it is equal to 2 times the median from A, that is AP square plus this BP square. This BP and PC, they are equal. Okay, because P, it is exactly halfway to BC. Okay, so this theorem, what you just saw, the Apollonius theorem, we will be using for solving our question. Here, we can rewrite, consider triangle. I just want you to focus on triangle DAB. Just focus on triangle DAB. Okay. So we can see that here AD square plus AB square, okay, that is equal to 2 times AP square plus BP square. Okay. You can see this is a triangle. AP can be considered as the median. Okay. So because midpoint of BD, that is this point P, from midpoint to the opposite vertex, I am drawing the median. So we have AD square plus AB square. It is equal to 2 times AP square plus BP square. So this is the guiding equation, what we are going to use for answering our question. Now let us convert the values that are given here. Okay. It is given BD, it is equal to 24 centimeters. Please observe BD, if it is 24, can I not see that DP, it has to be 12, and PB, it has to be 12, halfway through 12 plus 12 is 24. Please observe here, it is given AC, it is equal to 4 root 14. So the full length AC is 4 root 14. So what has to be AP? Half of 4 root 14, I know that is 2 root 14 it will come. In the same way, PC has to be 2 root 14, right? So I got those values there. It is given AB, it is given that it is equal to 16. So I will write that AB, it is equal to 16. Now look at the equation here. You are asked to find the length of this AD. AD is what I have asked you. So I can say here AD square plus AB square. You know AB is 16. So we will write 16 square. It is equal to 2 times AP square. I know AP it is equal to 2 root 40. So I can take 2 root 40 the whole square. Okay, that is 2 times AP square plus BP square. You know BP it is equal to 12. So I can deal with this as 12 square. Cool. So we have all these details with us. Only one element is missing, that is AD. So you can just take the square, multiply, simplify and all. So that will get you AD square. It is equal to 144 you will get. And solving this, I can see that AD, it is coming here as 12 centimeters. Okay, AD will come here as 12 centimeters. And that brings conclusion to our third question in this law. Dear students, before we are attempting the next question, let us deal with the special triangle that is this 30, 60, 90 triangle. Okay. So let me say if this is 90 degrees and I am considering that this corresponds to say 60 degrees. And let me say that this measurement, it will be 30 degrees. Like that if I am considering, please note, if I am calling this as triangle ABC, okay, I'll just mark the vertices also ABC. Okay, so please be aware, whatever be the measurement of the side which is opposite to the 30 degrees. See, this is 30 degrees. Opposite to 30 degrees, we have AB here, right? So whatever be the measurement of this side AB, which is actually opposite to 30 degrees. So I will put it this way, whatever comes opposite to 30 degrees, let me say that is equal to some P units. So whatever comes opposite to this 30, I can see that it is P. Double of that will come opposite to 90. So if this is P, opposite to 90, you know, it has to be 2P. In the same way, whatever comes opposite to 30, that value into root 3 will come opposite to 60. Okay, so for this 30, 60, 90, this given triangle, please be aware, this is how you can consider that the sides, they will be oriented. Opposite to 30, P, and opposite to 90, it will be 2P, and opposite to 60, it will be P root 3. Okay, so make a note of this. Now, with this, we will explain our fourth question. Let's read the question. In the figure, ABCD is a rhombus and angle ACB is 30 degrees. If the diagonal AC is x times diagonal DB, what is the value of this x? That is the question. So one thing that you have to understand with reference to the property of diagonals associated with a rhombus. So I shall just draw this diagram in a slightly enlarged way. Okay. There are two things which you have to take into account here. For a rhombus, you can, I'll just write it here, the diagonals. They bisect each other. The diagonals, they bisect each other because a rhombus is a peculiar type of parallelogram. So diagonals, they bisect each other at 90 degrees, at right angles. Okay. So this is the property that we are going to consider for solving our question. For a rhombus, the diagonals, they bisect each other at right angles. So I cannot claim that the diagonals are equal in measurement, but the diagonals, they bisect each other at right angles. Cool. So I can consider that this DE and this EB, measurement wise, they will be equal. AE, please note, it should be equal to EC. Measurement wise, they are equal and they cut at 90 degrees. Okay, please be aware of this. Okay. Now, in the question, if you observe further, ABCD is a rhombus, angle ACB, A to C, C to B. They say that this angle here, it is given to be 30 degrees. Okay, so I'll just mark this here. This is 30 degrees. Okay, so I'll just mark that 30 degrees. If the diagonal AC, it is x times diagonal DB, what is the value of x? That is the question. So what I am right now going to do here is, let me consider EB. Okay, assume, I'll just write it here, EB. Assume it is equal to some value P. Just put it that way. It is equal to some value P. Got it? So, I can say for sure that whatever comes opposite to 30, as this angle, it corresponds to this 90 degrees. I can say for sure that this angle, it has to be 60 degrees. So don't you see that this is actually a 30, 60, 90 scenario? So whatever comes opposite to 30, that value into root 3 should come opposite to 60. So this has to be P root 3 measurement wise, right? So I got EC is P root 3 and EB is equal to P. I got those two numbers. Now let me consider DE. DE will also be equal to P and AE, it is corresponding to P root 3 because for the rhombus, the diagonals, they bisect each other. Got my point? So that helps me to find out our AC, this diagonal AC, you know how much it will be? AC is equal to P root 3 plus P root 3. I can say that comes here as 2P root 3. And I can see that our BD, when we are considering BD, it will be equal to our BE plus ED, that is P plus P. I can say that value, it will come here as 2P. Now look at the question. The diagonal AC, they say it is x times the diagonal DB. What does they say? They say that 2P root 3, it is equal to x times, that is x into diagonal DB, that is BD, that is equal to 2P. So they say that 2P root 3, it is equal to x times 2P. So I can cancel this 2P here and that gets me x, it is equal to root 3. So I can see that here x, this value, it is equal to root 3. In the question you are asked to find what is the value of x, and thus I have identified here the final answer. It is equal to root 3 in this case. I hope this explanation, it is clear to you all, right? Students, take a look at the next question. It is given in the trapezium BCED, which is not drawn to scale. So they have taken the caveat here. This diagram, what you see here, it is not drawn to scale. They say that DE, it is parallel to BC. DE and BC, they are parallel to each other. They say DE, it is equal to 5 centimeters. So please observe here, this DE, 5 centimeters. DB, it is equal to 25 centimeters. So DB, this is 25 centimeters. Please observe, here itself we can say, when you look at the diagram, DE is appearing to be longer than DB. This is 5, this is 25, they say, but DE, it is appearing to be longer than our DB. And that is why it is given, the diagram, it is actually not drawn to scale. Okay, so just by looking at the lengths, don't consider that it is actually drawn in proportion. It is actually not drawn to scale. Keep that in mind. Okay, so it is given that here this DE, it is parallel to BC Further, they have told you DE, it is 5 centimeters, DB, it is 25 centimeters, and you can see that this BC, it is equal to 30 centimeters. So this is equal to 30 centimeters. Cool. So I will not write that BC 30 right now, but rather I am going to split this into two parts. So I'm just putting it like this. Okay, so I'm just dropping two perpendiculars from D to BC, also from E to BC like this. And let me say that they meet here at these respective points P and Q, like you can see. Okay, so I'm just putting it in that way. So I can thus see that BP plus PQ plus QC, that will be equal to BC, that is equal to 30 centimeters. That is what it is given in the question. I am putting that 30 centimeters into three segments, BP, PQ and QC. So can I not see that here PQ and our DE, they will be equal because it's a perpendicular that I have drawn from here, right? So PQ and DE, they should be equal to 5 units each, 5 centimeters each. I shall put it like this. Got it. So I'm just writing that number over there. Okay. What are the further things that they have told you? It is given DE is 5, DB, it is equal to 25. They have told you that is 25. BC, it is equal to 30. So the full length, it is 30. Further, they have told you the height of the trapezium, it is 24 centimeters. Height means what? The distance between the two parallel lines. That is the height of the trapezium. They have told you that that is equal to 24 centimeters. Got it? So you can see that here, this is 24, sorry, this is 24, this is 25. I can see that's a perpendicular that I have dropped. So this angle BPD, it has to be 90 degrees. For your understanding, I shall just snip this portion and show you. Just look at the triangle there. Okay, don't look anything else. Just focus on the triangle over here. Okay, so I can consider that this will be 90 degrees. You can see that this is 24, this is BP, and I can say this is DB, which is 25. Okay, so from this, can you not see that here, BP, the measurement will be 25 square minus 24 square. That comes as 49. Root of that will give you BP. So can you not see that BP, it has to be equal to 7 units, right? I can see that this BP, this has to be 7 units, 7 centimeters. So I can say BP is 7, PQ it is equal to 5. So will that not give me QC that is equal to the remaining 18? So that 18 plus 7 plus 5, that is equal to 30. I will get QC here. This measurement, it is equal to 18 centimeters. Got the point? And I know that QE, it is equal to 24 centimeters. You can see that because it's the height of the trapezium, it is given in the question. That is equal to 24. And kindly recall 3, 4, 5, it's a Pythagorean triplet, right? So if I'm going to multiply this guy with 6, what will happen? 18, 24, 30 will form a Pythagorean triplet. Okay, so I just want you guys to make a note of this triangle on the right hand side. I'll just snip this portion alone and show you something. Just look at the right hand side alone. So don't you see that we have a right angled triangle here? Yes. We can see that this is 24. We can see that this is 80. So this EC under consideration, it has to be 30. Okay, please note this has to be 30. EC, this has to be 30. Got it? So that way, we can see that the sides of this trapezium, we have just calculated it. The measurement of the lengths. Okay. Now, if that is taken care, we can easily find the perimeter of the trapezium. What should I do? This 25 plus 5 gives you 30. We can see that this is equal to 30. And we can see that our BC, the full length in the question it is given, it is equal to 30. So it's all about adding 30 plus 30 plus 30. And that gets you the perimeter of the trapezium. I can see the answer. It will come here as 90 centimeters. Got it? So as far as our fifth question it is concerned, 90 centimeters is going to be our answer. All right. I hope this explanations, they are clear to you. Any doubts, feel free to get back to me.